Okay, what we have here is the 2-liter stainless steel reservoir. It's also a reactor chamber. It's also a safety release valve. Right here we got springs that are rated for about 200 pounds each, and 4-inch stainless steel tube, so it works out to about 100 and I believe 50 pounds before this pressure will relieve. So if you ever have an explosion inside here, it's going to release the pressure before the metal explodes and blows up. Up on the top too, it's not on here right now, but we have also a pressure relief valve that's going to relieve at a lower pressure than this top here. So this will also go in, there'll be a tube going in here for an overflow. We'll be running water, distilled water with a catalyst, sodium hydroxide, so it's something you don't want to get sprayed in the face or on anything, or you get hurt, injured. This is a liquid filled gauge, goes to 300 psi, and this system is designed, we've already had this thing to 30 psi. The more pressure you have, back pressure, the more amperage the hydrogen cell can generate. Otherwise it'll basically cavitate the hydrogen generator and it'll be pulsing the amp draw, and you won't be able to draw that much amp, not that much gas. So we have to put a back pressure on the system here to increase the amp flow as well as the gas production. Down here we have the this is the inlet port from the hydrogen generator. Right over here we have a manual. This is a needle valve, precision needle valve. It's calibrated. Let me see if you can see it. It's got numbers on it. This is going to be replaced with a automatic pressure relief valve, so we can set it from about 10-20 psi all the way up to this is designed to run about 120 psi. That's the word I got from Professor Wells before he disappeared from the scene. He said run the gas about 120 psi, that's when the magic begins, and get the water to boil. So this water already at 125 amps, we get a single dual element 3/4 inch stainless steel tube cell, patterned after the Stan Meyer's tube cell, but it's got O-rings on the end, forces the water in one end, out the other end. This at 100 and I take that back, at 125 amps we need about 30 psi to keep the cell to go from going into cavitation. But we're running this thing up, eventually going to be running up to 120 psi. I've already had another cell up to about 80-90 psi. It produces enough steam in here that it acts as a fire suppression against the hydrogen and oxygen recombining and causing a spark. Normal HHO generators, you don't want to go above 12 psi. This system was designed to run at 120 psi, but you need to have temperature high enough of the water to produce steam, so it helps suppress any spark that's going to happen from the energy levels dropping of the HHO gas. At 125 amps, the hydrogen generator is running about 250-260 degrees, so the water is already boiling, but when you have pressure in the system, it's going to keep it from actually boiling over inside the generator. At 120 psi, that's equivalent to over 350 degrees, I believe, but we're not running that water. We don't tend to run the water that hot, but we intend to run at least 120 psi to keep it from actually producing steam inside here. And any steam that does go out, it will be recycled in a bubbler, and that bubbled water will eventually be pumped back in here under pressure with a automatic level system. So there you have it.